Hello everyone. Let's talk about scientific notation. Scientific notation is a way of writing very large or very small numbers in the form a times 10 raised to the power of n, where your first factor, which is a, should be equal to or greater than 1 but less than 10, and the value of the second factor is an integral power of 10 raised to the power of n, where your n is the number of times that the decimal point is moved either to the left or to the right until it reaches the first significant digit. Remember that there should only be one digit to the left of the decimal point. Let us have examples. We have, for example, we have 150 million. 150 million is the distance of the earth from the sun in kilometer. So that's actually very large number. So how are we going to change this into scientific notation? First is we have to identify the location of our decimal point. Our decimal point is located here. So let us move our decimal point to the left and count the number of times. So we have 1, 2, 3, 4, 5, 6, 7, 8. So we have to stop here since we already have one digit left at the left of our decimal point, which is 1. So how are we going to write it in scientific notation? So we have 1.5. You should include 5 because 5 is still a significant digit. So 1.5 times 10 raised to the power of, we move 8 times, so 10 raised to the power of 8. That is positive since moving our decimal point to the right, to the left, indicates a positive exponent. So this is our answer. That's so easy. Then another one. Say we have 1 million. It is 1 million. 1 meter is equivalent to 1 million microns. So how are we going to change this into scientific notation? So let us count. Our decimal point is located here. So let us count and move our decimal point. So 1, 2, 3, 4, 5, 6. So we have to stop here since we have our significant digit, one number at the left of our decimal point. So it is written as 1 times 10 raised to the 6th power. So we have this. Another example. Let us have 0.00075. So this is read as 75 hundred thousandths. Since this is decimal, so 100 thousandths. So changing this very small number in scientific notation, we have to count and move our decimal point to the right. So let us have 1, 2, 3, 4. We have to stop after 7 since we already have 7 as one significant digits at the left of our decimal point. So we write this one as 7.5. You have to include 5 because 5 is still a significant digit here. So 7.5 times 10 raised to the power of, if you move your decimal point to the right, it indicates a negative exponent. So you move 4 times. So that is negative 4. So this is our scientific notation for this small number. Another one. Example number 4. Let us have 0.1, 2, 3, 4, 5, 6, 7. So you have 0.000000001. This is actually read as, how many zeros do we have? This is actually read as 100 millionths already. A very small number. 100 millionths is the diameter of a hydrogen atom in centimeter. So that is very small. How are we going to change this in scientific notation? So let us count and move our decimal point to the right. So we have 1, 2, 3, 4, 5, 6, 7, 8. We have to stop after 1 since we already have 1 as one significant digit at the left of our decimal point. So we have to move to stop here. So we can write it as 1 times 10 raised to the power of, how many times do we move? That is 8 times. So we have negative 8. So that is 1 times 10 to the negative 8 power. Okay. Another example. We have 5.13 times 10 to the third power. 5.13 times 10 to the third power is the speed of sound in meters per second. So that actually is very fast. Now let's change this into standard form. This is in scientific notation form. So let us try to change from scientific notation to standard form, or express this in a large number, or in a decimal form or standard form. So since you have positive exponent, that means that you will move your decimal point to the right. So that is 5.13. Let us count. 3 times 1, 2, 3. So our decimal point is located here. So you have to add 0. So our standard form for this decimal notation, for this scientific notation is 5,130. So that is our answer. Changing scientific notation to standard form. Another. We have 5.89 times 10 to the negative 7. Blue light has a wavelength of 5.89 times 10 to the negative 7 microns. So let's change this into standard form or decimal form, since that is negative exponent, that is negative 7. That means our number is in decimal form. So let us count. That is 5.89. Let us count. That is positive, we will go to the right. Since this is negative, we will go to the left. So count 7, 1, 2, 3, 4, 5, 6, 7. Your decimal point will stop here. Add zeros. 6. Okay. So our decimal form for this scientific notation is 0.589. So this is our answer. So it's actually very easy changing large or small numbers to scientific notation and vice versa. Here's few exercises for you to answer. Comment down below and let's see if you get it right. Thank you for watching.